So we're now going to discuss what we mean by the limit of a function, and we're going to do it informally. So when I write lim x goes to a, fx is equal to L, what do I mean by this? Well, what I mean is that as x gets closer to a, f of x will get closer to L. Now, in a minute, we're going to expand this into the formal definition. In the film, that almost comes right after this. But since the definition is sort of technical, I first want to convince you that this is just common sense. So in order to do this, let's try to graph a function in Python. And the one I have in mind is sine x divided by x. So we need to import NumPy. And since we're going to look at the graph, we import matplotlib. And then we need our x-axis. Let's do from -10, 10. So let's do this with fairly few points, 11 points. Y equals f of x. And then plt plot x comma y. So, okay, that kind of looks ugly, so let's do more points here. So it looks a bit nicer, let's do more points, and so forth. What is it that we should notice here? So if we look here, we see that, first of all, why is there a gap here? Well, the gap here is because Python is trying to compute the value of this guy at 0, and that's not possible, because at 0 we would be dividing by 0. So the value exactly here, Python will not compute. So if you force Python to show us what it's really doing, it's just computing these dots here and then drawing a straight line between them. And since he's unable to compute this dot here, it's just ignoring this part. So perhaps we should do like this. Okay, so we're getting both the guess that Python is making and the actual values it's computing. But the thing is now, what we can do is still compute the limit here. So we can still compute the limit of sine x divided by x as x goes to 0 in this case. What would that limit be? Well, that limit would be whatever this expression here approaches as x approaches 0. Notice, as x approaches 0, what y value are we approaching? Well, the height here is 1. Could it be that we're approaching 1? So let's see. Let's, instead of 41, do 401. Let's go crazy. So now you can see that these dots are getting really, really tight here to 1. So to zoom in here to see what's going on, I would do here plt x lim and then do from minus 0.1 to 0.1 like this. Maybe that's a bit too close. Let's do 0.5. So here, notice that we're really, really getting close to 1 here, right? So if I ignore this again, go back from 10 to 10, like this, we see the graph here, and let's even take away these dots. Then, I mean, if we get served this graph, then it kind of seems obvious that as x gets closer to 0, this thing here will get closer to 1, right? And in fact, there's a rule of thumb I like to use. It's that if you have an expression or a function and you want to know its limit when x approaches some point, just let your finger trace the graph as the corresponding x value is getting closer to, well, 0 in this case. And whatever height your finger ends up at, well, that's the value of your limit. Notice this function here is not defined at 0, but it does have a limit at 0. As part of the reason why we care about limits, it allows us to study functions at points where they're not defined.